Welcome, nobody. Oh, hello. We have a few people here. Very nice. Um, we're working on this motor and fitting it here, which it does fit, which is good, but we gotta create some mounting for it. Yeah. How should I put it in? I think I have to insert it this way. So then I'm thinking that why don't I do plane through two edges, just randomly pick that one and that one, and then we take this, split that there. Okay, don't forget those two stay. Okay. Ooh. We are working on the motor mounting. Thanks for stopping in, Cher. It's nice to see you again. So I'm trying to the motor fits in, but I'm just trying to figure out a way to kind of assemble, I guess. Um, Plane at angle, 90 degrees. Did I? Where is it? Let's see here. I think I need plane at angle, 90. Okay. So right, and then yeah. Okay. Split this body here. Okay. Okay. And then recombine here and here. Okay. Cool. And now this is where the motor goes. Weird. Very, very weird. But okay. But okay. Um, hmm. We also know that we're going to need like a cylinder thing. But let's focus. Let's focus. Because where did the linkages go? The entire motor assembly is internal. The linkages will go, starting here, just like in this one. right? And this one, they're over here. But in this one, they're going to be over here, but just internal. So we're going to have to reserve maybe this amount, like from this plane onward for linkages, I think. And then the pressure vessel will be from here to the back, essentially. If we can make it such. If we're smart, we're working on the motor housing. So I have it carved out here. The motor is here. Valve motor, okay, sits right there. And that's going to be like the cover for it, depending on a couple things, I guess. But I think that works as a cover for now. But we do have to think about the other things that are going to be here. However, I should be able to sneak in some screws, I believe, because there's not going to be any mechanisms in this spot here, in this square, because there's going to be a linkage starting there. But here's safe for screw holes to pass through for mounting this cover. Let's see if we can do that. Okay. Should be good for 2mm screw hole. That should be just fine. Okay. And I think we can pretty much just go just to there. It should not cause any problems. Maybe it does. Let's go -7. No, -5. Okay, -5. 5mm of thread engagement should be fine. Thank you, Real Snail 3D. I appreciate you tuning in. I'm looking at this thing here. Okay. 2 sides. Bam. Okay. Okay. Then we just take this and this. 0.1. No. 1. No. -0.2. Okay. And we're going all the way. So the 12mm screw will be fine. We just need to fillet this 1mm. And okay, that will work, right? That will surely work. Yeah. Yeah. We can make this work for sure, definitely. Yeah. Can definitely fit a mechanism there. Then I do want to screw over here, I think, as well. But it kind of has to be far because this is where the wires are going to go. I'm going to do a chain selection. What's up, Cream? We got Cream in the house. Weren't you the villain of the Supergirl? 1.9. Okay. So -5. Symmetrical. No, 2 sides. And this side goes all the way through. What is the time? It's 11:30 a.m. Cream Cream does not know Supergirl. Okay, guys? He does not. Okay. Jam for this. 1 millimeter. Okay. 3 screws should be okay. Okay, we're making some headway. This is nice. I didn't expect to make any headway at all. Cool. There's a bit of a thin wall situation going on here. Let's find out how thin it is. Obviously, it's a circle, so it's not going to be a huge deal. 0.239, everybody. Okay. That will certainly poke out, but not a big deal. If we do, okay, because how much is this, right? This has got to be okay. 0.739, yeah, that'll be fine. We're going to expect this motor to have a thin line of silver be visible underneath the rugged exterior of this. And if we don't want that, later we can just add a thin thing that goes on top, but it really doesn't matter that much. I'm just going to get rid of this so that we don't have any thin walls here. Because that's the direction it goes, obviously. So boom, boom. Let's try -1. That probably makes it a little better. Let's try -1.5. That should be good. Front to back length of the Web3. We will measure that in a moment. Just for you, just because you asked. How nice is that? Okay, let's go with that. And we'll add some fillets, just because I'm nice like that. Not there. There. Okay. You see how that's going to work? So the motor is going to be just visible under here, and that's because otherwise there would just be a thin wall of plastic, and that's kind of useless. So whatever. Okay, great. So, oh, front to back length, you said. I mean, it's right here. Like, this is what it's going to look like. Like, I have this. This is what was in the video that you guys saw. I love this thing. It's so cool. It's like, yeah. It's so easy. Yeah. Thanks, Cream. Appreciate that. Cream is just trying to understand. He's just pretending to understand everything I'm saying, and that's okay because I do that to myself too. Front to back length is 57.89 millimeters. And of course it's the same with this, but we're going to measure it anyway. That's actually an interesting thing. How far off are we? 58 on the dot. So we're about 0.1 millimeters off, which is pretty like respectable, I'd say, for 3D printing, a 3D printed assembly. Cool. So that's a little bit over 2 inches. Yeah. But size doesn't matter. Let's see here. So I think that I want to do the wires here. And I know where they're going to go because they come out of here, obviously. So first things first, I'm going to do a 1.2 millimeter wall. Get rid of this and that and that. Offset this circle also by 1.2 millimeters. And then I'm just going to like do a vertical line there to make it streamlined. Line there. So wires are going to come off of here. And I think that should be okay. I should probably just do like maybe that. And then that. Should be fine. Okay. Okay. And then this. Or maybe I just do this. Okay. 2.28 inches. Thank you. Thank you. That's what we need to know. If I get rid of this motor, because I don't want to see it anymore. The thing is, I carved out, these spots for all the junk that's in the back of the motor. The little shaft section, this circle here, and then the two solder wire attachment points. So we can actually just take this like all the way back because this is a square thing. Yeah, so that'll work. Okay. So the motor sits there, the wires come off there, and there's only 2 wires. I think, I mean, it's a little bit scary because there's not like a shit ton of room. I don't know. I have to think about this because I don't want to have to like desolder wires to disassemble this, obviously. So maybe I want a space for a connector. That would be nice. But that would have to be like somewhere in here, I think. Oh shit. Yeah, don't forget the fact that all the other wires are gonna have to go through here somehow. Oh, darn. We're doing great, everybody. Everybody, we are doing so good. The wires are gonna go into here. obviously, and there's a lot of empty space in this, so that's something. But then in terms of how they get everywhere else, oh god. All right, it's gonna be tricky. Not all of the prototyping. I mean, if you saw my recent video, then yeah, that's SLA printing for little mechanical parts that require a lot of detail. But these large parts here are just FDM printed with PLA. So that's that. Gotta fix this button. Keeps getting stuck. All right, I'm going to, call me crazy, switch gears. FDM bracelet design time. Just because I need a break from the web. Okay. Okay. Oh yeah, and I can go to KiCad. Let's go to the 3D viewer. It looks good. So I want to get this. Oh, that's such a shame. No, I think it'll be fine. I don't want to waste time finding 3D models. Let's get that step. How do you switch filament mid-print for the flexible trigger between two TPU grades on a Prusa Mark IV? So in the Prusa slicer, you can implement filament changes, wherever you want. So for instance, with this part, I have some gears here, and if we go to the G code, I can go mid-print, like even on a multi-part print like this one where it does them sequentially, I can go change material there. Oh, actually, I was wrong. I can't do that on a multi-part print. Okay, let's change the settings. So we uncheck complete individual objects. We slice now. Although I think it... So yeah, you can see here. There is the filament change. And so it's going to do that automatically, which is really nice. And so I've made sure... let me see. I think... Where's the other slider? Because... Bro, wait, where is the other slider? Where's the per layer slider? What's going on? Am I crazy? I thought that existed. What? I feel like I'm having a Mandela effect right now. Do you guys, anybody use Prusa Slicer? Like, what happened to your camera? Yeah, I'm welcome. Hi, I'm Gleep Glorp. Nice to meet you. From the planet Glomber. So, does anyone use Prusa Slicer? Does anyone remember that there's another slider that we can look at how it prints per layer? I feel like I'm going crazy. me try. I'm just going to try to. It automatically pauses the print and you manually switch to the filament. Yes, that's correct. I have another printer at the place that I'm moving to that has a multi-material printer, so that'll be easier for this, but that is the current strategy, yes. So most of the, all the filament changes are in a layer, so from layer to layer, which is great. That's how I've designed it to make it easier. But there is one layer where I need to do like one little like line of one material and then go to the other side. Yeah, I agree. It should be on the right side. On the right side. Hold on a minute. Okay. Let's open it back up. Okay. No. So for instance, I can open a step file in Prusa Slicer, which is kind of wild. And so it's the one we just exported from KiCad. Not that we actually want to print this, of course, but it's kind of funny that we can. This is so weird. I don't even know what the slicer is doing here. There, yeah, there it is, right here. It's on the bottom. Okay, so I wasn't tripping. So it doesn't look like I can add a change, a filament change in a layer, which is kind of stupid. But there are ways around that. There are ways around that. So no worries. That won't be too bad. I'm not worried about it. This is funny though. Look at this. USB-C port. All right, cool. Done with that. Go away. Gotcha. Okay. So let's go to my force myography project. It's been a while since they don't update it. Yeah. I'm always annoyed when they are like, oh, would you like to update? I'm like, not really. It works fine. So let's upload this. Which multi-material prism is this? Not very prism. Also, it's the N. What is it? It's an Anycubic something X. What is it called? Anycubic Cobra X, I think. Yeah, this one. Yeah, it works really well. Yeah. Anycubic Cobra X. It's really cheap. So 4 filaments going into a single print head. It's pretty good. I'm surprised how well it works. Of course, the problem with that is you need to do a lot of purging, which is annoying, but you just, I feel like don't go crazy with the multi-material printing, like there's no need to go crazy with it when you're just doing engineering and you're not making like anything artistic. Yeah. So how do I want to do this? Because I think that I'm still going to need a flexible housing for this. But yeah, I'm still going to need a flexible housing for this, obviously. Actually, this is not good. I don't get the traces. I have to do a different export. Export, solder mask, silk screen, cut vias, export tracks, pad zones, fuse shapes. Let's just do all of that. Let's do all of that. The works. Give me the works. Yeah, but it can. I've used it before. Yeah. It can automatically update the temperature. Yeah, but you're right. You have to do a lot of purging because it's two different materials. So if you do it wrong, then your print is just going to fall apart. Yeah, I had done a print where, for my first time ever using different material as support material, and it's amazing like how amazing it is. Like the support material just breaks off. Like that's just amazing. 610. What up? Now it's a party. Okay, this is gonna take a minute, but let me just think. So I'm gonna need a little house, because this has 3 sections of rigid material. Um, so I feel like I might as well do like a thick body, thick body, thick body, with thin body in between. That should be fine as long as as long as it's really thin. and I think what do I think? I think I can do that in like just a couple parts maybe. I don't want to like seal it in, but could be. It's like white material. So I could just slide it over one side. I just need the battery coming out and then a couple of wires coming out here. Do I want to have, I think I want to have, yeah, 4-pin connector. Four-pin connector for external trigger things. Aerial flips. Nice, dude. That's always hard. Standard cartwheeling, trying to get my arms to stop touching the ground. It is tough. It is tough. I remember getting a one-handed cartwheel. That was enough for me. No-handed cartwheel, yikes. I am not flexible enough for that. Did this finish exporting? Yes. It does not want to be alive for some reason, but it's okay. Okay. Yes, I'm the CAD goblin. Da 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 da. You know. Not that hard, at least the capoeira one. Fuck yeah. We got the dance fighter in the chat. That's what I'm talking about. Go away, AI data centers. Jesus Christ. Yeah, this is pretty cool. I mean, this is almost a B kick though. Like this is almost a butterfly kick. It is not. It's definitely more an aerial, but this is definitely the kind of one where you can turn your butterfly kick into an aerial by just doing a better butterfly kick and kicking your legs higher. Which butterfly kick is not that bad, so that makes sense. But I'm also, should I mention I'm 6'2"? Okay, no excuses, I guess. It's fine. CAD Goblin, what have you done? Yep, that's me. That's me. Can we insert this one? There we go. All right. Look at this. Look at this. Okay, so there's our sensor pads. So we gotta make sure. Well, you know what? You know what I don't have here are the stiffeners. I'm gonna make them. You can go make it. Okay. Blood spider is short as heck, dude. Sorry, that was mean. 14 millimeters. Wow, PCB way is precise. That's incredible. $14. Then this one and this one. I think the space between is the same on both. We'll go for 3.6. I think that's going to be good enough. What do you mean over constrained sketch? Stop that. I think these two are the same length. 10. Yeah. 10.1. Okay. Great. Stiffener complete. I do have some circles here to contend with, though. They gave me some cutouts here for these pins, so I do have some stuff poking through the stiffener. I think I chose 1 millimeter, if not 0.8. 0.8. You got it. Still pretty thick. Okay, cool. I'm gonna make these all part of the same component because I don't have the patience for this. Okay. Okay. Stiffener. That's what this is. All right. Great. 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 Okay. Call this FMG housing. Okay, don't overcomplicate this. Try to get this done faster than you usually do. How about that? That's the goblin talking. Coward. We have a new world to conquer. So there is going to low Kirkenuanly be a bunch of stuff on here, which I may need to contend with. So I'm going to do that also. So we got that flexible 3D printable material. So I'm going to just get all these circles here. Boom. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay. So we've got these materials here. We're going to print these on. We're going to print those on. Yes, the semiconductive material layer, exactly. So if we're going to do this right, should be about the same thickness there. But then we're going to have to come with the bar. It's not, no, the point 0.9, that's nothing. We can do that. Let's do some filleting, just because comfy and other stuff. Oop. Maybe like that, right? How about that? That looks nice. Okay, so we're going to print that on here. Sleep. Yeah, exactly. So also, I want to think about the fact that we're going to need to make a dang, now I feel like I really should have gotten those 3D models. I'll just model them. Just model them real quick. No biggie. No big deal. No big deal. Okay. It's just a couple of rectangles, right? What is it? Those are the only missing components. So this one is also wrong. Maybe let's get rid of that one. Okay. So we've got some rectangles. We've got rectangle. We've got rectangle. got rectangle, and we've got rectangle. Great. First things first. Rectangle from here. Well, okay, we need some datums. Okay, don't do without the datums. All right. Datum, datum, datum. Datum. Well, datum, datum. Okay. You know, I'm gonna also get datum, datum, datum. Nope, not that whole thing, please. That would be really kind of annoying. Datum, datum. Hooray! Okay. What is happening? I'm not doing this. There we go. Then we need dimensions. You know, sometimes a computer is like, no, you're still asking me to do something. I have to do it. Even though you stopped asking like 2 minutes ago. What's up with that? Any computer guys can tell me what's going on with that? Okay, that's a 0.8. This right here. This is also 0.8. Yeah, but it's fine. It's okay. All right? We're going to make do. We just make do with what we have. Dude, I think this file is slow. The other one wasn't nearly as slow. I think this file is slow because there's too many graphics. See, I was about to say, see, now it seems faster. Let me do, I think I can do some graphic settings. I'm not using a remote desktop, but maybe this will help anyway. I don't know. Nope, doesn't seem like it. Whatever. It's fine. I don't care. There got anything else going on? Maybe I gotta quit some programs here. Okay. Let's just continue. 12.3 by 11.5. Okay. Here we're going to do a line there and a line there. And if we select both of these and say, hey, that's a midpoint. No, no. Stop it. We say, hey, that's a midpoint. All right. Okay, then you have to contend with this. $5.6. And this. $3.9. Just give it 4, just for safety. Great. That's the SD card. It's really the zooming. Okay. Just making my constraints. Boom. Got him. Just making my constraints. Boom. 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 Okay. Now we have the LED and the button. Button 5.4 wide. And how tall? 3.3. Sure. This guy, what am I? This guy, LED, call it 3 by, wait, by 2.4. Okay. Let's go for the highest one. 3.5. Okay, and then this one is how tall? 1.9. This one, really, really small. 1.1. Well, that plus 1.1. Okay. This one, that plus 1.9. I do know that I may have to contend with the lead situation here. Let's just do a couple things. Here's what we do. Rectangle, center rectangle. I'm going to do 1 by 0.8. Sorry, we're going to do 1.6 by 1.6. Okay. Then we're going to take this rectangle right here, copy it, paste it, move here to here. Okay. Paste again, move from here to here. Got it. Paste again, move from here to here. Great. All right. Now we take this, we take that, we take this, and we take that. We go from object, and we're going to go up 1 millimeter. And you know what else I'm going to do? I'm going to move that all the way over here. That's the front part. Anything else we should look at? This one is up a little bit higher, and this one comes further that way. Call it 4. Okay, and then just because this one's a little more complex, I'm going to map out the place where the SD card goes in. 9.81. I'll do a center slot. (9.81/2). (1.76). times 2. Did I? Okay. 9.81 minus 1.76 times 2. What am I missing? Did I calculate that right? Yeah, 9.81. 9.9. A little bit longer. And this depth here, look, if I got it right, I got it right. 1.64. All right, it doesn't look like that in real life, but those are the measurements. Okay. Well, let me get a rectangle here also. Great. And boom, 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 boom. -1.3. Okay, and then from here, going to do a center rectangle. To the width of the whole thing. (11.64). And this will be the height of the whole thing. .2. Those become collinear. Great. Boom, 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 boom. Well, we just modeled an SD card slot. How about that? Don't have to have it go all the way in. All right, cool. Fun and great. Diode, button. Can do some light filleting here, just because I know it's there. LED. Components from these. This will be SD. Components from these. Love that. Cool. These components here, I'm going to make components of them, but then I want to make sure they all go into the same thing. So this is something annoying that I actually haven't figured out yet, how to create a single component from multiple bodies that exist. This is the only way that I know how. And it's kind of tedious. Okay. Now we have component 8. Call this sensor pads. Sensor lads? What's up, lads? No, sensor pads. All right. Sip of my kiwi milk. So, okay. Yeah. I'm trying to decide what to do first. No, I'm not. I already decided what to do first. So the next thing I want to do is the fact that I'm going to have to print these sensor pads, great. But you'll see I already have this complete here. So what I need to do is I need to essentially create a sort of stand for this that will be printed on the printer. Then I'll set this in the printer so it's constrained, and then it'll continue with printing the pads onto this board. That's always been the plan, but I need to make that stand now. And I think it'll be pretty simple. Why don't I just why don't I just do this? If I do a plane here, and I'm going to get this. We're going to need to have some tape when we do this for sure, but not a big deal. Let's get a point there and a point there. Make a ready rectangle. Offset that rectangle. Chain selection, please, Mr. Chain selection. Chain selection. Offset that rectangle by 6 millimeters. That should be fine. We get this whole rectangle. We go down however much we need. -6 millimeters. New body. Okay, then we'll see if this works. This could be insane. We're trying to do this as quick as possible. This is the body, the tool bodies. So here's the part where I am wondering. If I break this link, that's going to take a second. So I'm breaking the link. I'm basically trying to make this board into one body so that I can like just use it to cut stuff. It's going to be interesting because there's a lot of subcomponents here. There's a lot of subcomponents here. Okay, let me isolate this. Let me isolate this. So many subcomponents. That's a single body. That's a single body. So if I were to say, just take the main, the PCB, take that body, copy that. Great, we love that. That's good. That's now here. PCB single body. I'm going to do a bunch of combinations. My goodness. So we're going to keep tools. And we're going to do this one, this one, this one. I hope this works. This one, 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 this one. I'm going all out. This one, and this one, this one, and then the 16, well, this one too. Then the 16 resistors. This one. Yes, and this one. Yes, and that one. Yes, yes, and even this one. And this one. And this one. Oh boy. And this one. It's getting slower. Come on, buddy. And this one. Come on, man. You've got this. And this one. You can do it. This one. So forge ahead. Forge ahead. Forge ahead. We're more than halfway there. This one. Okay, that's it. Just 5 left. And this one. Careful. Careful now with the mouse. Don't slide it around or the computer will get confused. And this one, 3 left. You've got this. And this one. You've got it. And this one. That's it, that's it, that's it. Buddy, what do you expect me to do? And this one. I feel like, Shira, you low-key judging me all the time. But it's fine. We all have to hold up to scrutiny. All right, we're going to try that. Hit OK. Oh, I think it worked. Well, actually, it didn't work. It didn't work at all. It combines some stuff, but not really. Okay, let's get rid of this. Let's see what we have. It still looks like we have individual bodies, which is really weird. But why is that? They couldn't be combined for some reason. Oh, of course, because they are sitting off of it. So if I take this, by the way, what is up with this? Let me remedy this situation here. Actually, this will be super easy to fix. Whoa, 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 whoa. Let me get that again. Plane here. Project surface of this plane. Boom. Boom. Another rectangle, please. Take that rectangle and just go all the way to here. And we're going to join, and this is going to have all those bodies go together. That's right. Yeah, I hit enter. What about it? Yeah, what about it? I'm brave. There it is. It's really strange that it colored them back the way they used to be colored. That's pretty odd, I'm not going to lie. But that is now a single body, so we can't complain. The next thing to add, is it a crime to use AI for code? Personally, I'm growing a distaste for vibe coding. Sometimes it's good to save time. If you're looking to learn how to code, not a very good thing to do. Depends what your goals are. I'm going to take this, and we're going to keep the tools, but we're going to add this and that. That USB-C is, of course, going to need some work after the fact to make it fit. Okay. I think that worked. Nice. Okay. Then let's get this and that and this and that together as well. This. Boom. 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 Okay. Trying to program Gabe Newell style. Valve. Void setup 1 and void loop 1. Yeah, and then you can call those. Is that your plan? It's a good plan. Get rid of these. Okay, so this is a surface. And this is what we want to use to cut it with. What happens? What happens? What happens? Cut. Please work. I know the geometry is complicated, but you can do it. I believe in you. And if I believe in you, you can do anything. What? Did we create something odd here? Looks like we did. Looks like we did. The realization that it doesn't have to be, oh, that doesn't have to be chronological. Yeah, that's right. Okay. Really interesting thing has happened here. What's going on with the USB port, dude? Are we serious right now? I think. Oh, okay. Grow up. Okay, I think what this has taught me. This has taught me a couple things. All I know is I need to just kind of carve around all of this stuff. That's what I'm gonna do. But now I know where it is at least. That's good. So take that one. I think the USB port kind of sits off of it a little bit, right? Yeah. So we definitely need that space. Okay, that'll work. Carve out that one and this one. And don't mind me just doing the most random stuff possible. And this one. And this one. And we're just going to make sure that these are equal. Just cuz, I don't know. Great. I'm concerned that there's going to be too many shapes to deal with. Actually, yeah, I'm going to use the cut tool. That's what I'm going to do. That's what I'm going to do. Sorry, sir, we are not extruding today. Okay, just had to hit the save button, so give me a second. Solid, split body. Because who cares if these things go all the way through? Not me. Not me. Are you serious? Okay, we're gonna have to do one at a time. Whatever. Okay, and we gotta find the sketch again. What's going on? What's this project? We are working on the housing for the force myography research bracelet. And are we being serious right now? Okay. Here's what I'm gonna do instead. I'm gonna copy, or rather, project all the rectangular lines that you see here. Boom, 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 and boom, whoa, boom, whoa, 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 boom, boom, boom. Like, I also want to draw another rectangle too, just because it's probably going to be a good idea to do that. Yeah, that'll work. Okay, I want to real quick hide these sketches to go to there. Cutting that body only. Okay, and then I'm going to see this sketch again. Take these rectangles and say, hey, I think that you need to go all the way through. And you do. It's true. And then I can get rid of this one. How's about that? Okay, so this will work. It will sit right there, except for the part where I've already soldered the power connector. So I've got to make sure. Boy, am I getting a sore throat? My goodness. Tell me why I was worried about infecting you guys. I still don't really understand how computers work. All right. Goodness me. Don't do this on stream. Come on. You've got so much life left to live. This is gonna have to go -3. Hold on. 3, I guess. Symmetrical. Monkey brain core. This all the way here. This is just so, you know, it doesn't matter that I already connected the power lines, so this will fit nicely. Please don't do a dumb thing. You did a dumb thing. Let's do not the dumb thing, please. Okay. Yeah, we'll do a fillet. Yeah, I'm a fillet. Yeah, I'm a simp. Mayonnaise on an escalator. I'm going upstairs, so see you later. All right. That will work. So this sits here. You see that? How much space there is for everything to just sit. Let's check out that section view, that sweet, sweet section view. Okay. Oh yeah, resistor's got a spot there. Multiplexer has a spot there. This stuff has spots there. Everything is good. All right. So what's going to happen is we're going to print I wonder if I can make a new component with all these things. All PCB. Please work. What the heck? Okay, that doesn't work. Great. We're going to do a new component. Call it all PCB. And all of these guys are going into it. Now we can just do that. Okay. And we need to activate this again. All right, so how it's going to work on the printer. We're going to print this structure here. You can use a direct pull without that dumb thing if you just click a point edge where you want it to. I mean, yeah, that's what I did, but it doesn't always. I feel like, if I understand what you're saying, I feel like it always like it can't always interpret when I go right to the edge if it's supposed to go through the edge or through the surface or keep the surface. You know what I mean? So you always have to go through the surface. Uh, that's what I have found. I don't know. You're probably saying something, I think, and I apologize. So we're going to print this on the printer, set the PCB in, tape it down on either side, and then print this. Boom. Cinema. Absolute cinema. How about that? How about that? That's pretty cool. Let's save this. So that's that's not the housing, right? That's a manufacturing process that we just engineered, which is fine. So now we have to do the housing, which comes after. Yeah, and for that, we've got a couple decisions to make. I need more coffee. Maybe I should have some water, given that my throat is disappearing. Let's try that. Okay. Got the water. Okay. So we want a couple things. The wires need to stick out. Hang on a second. I thought I did a thing. Where is that thing I did? Not that one. What do you mean missing profiles? There. I'm going to keep those. Okay. We need these wires sticking out, so there's going to be 3 wires. And then this thing, battery, which the battery can just be like right there, no problem, sitting on top. Should I do? Should I print this the way I want? I think it doesn't matter. It doesn't matter. Go here. 0.1. Okay. I'm going to look at this. How we need to print this here. I want to project this point, this point, this point, this point, Flex watch lights up. Next step, syncing into our real time. Nice. That's fantastic. What I'm doing is planning stuff. Oh shit! My bad. Thank you, 5 loyal viewers. Thank you, Rick. Yeah, that's my bad. But I'm not a streamer. All right. Yeah, I think I'll just draw some points, man. What's wrong with points? Yes, welcome, Mystic Turtle. Finally, a stream before you have to leave for work. I am proud to have you here, and I am pleased that you could make it. I am straight up drawing points. Don't hate me. Oh, we got a paradoxical nature in here. Nice. I don't think anybody said average viewer, by the way. He just said a loyal viewer, which is a compliment, of course. Lock that in place. Got some points here. Should I draw some lines? Why not? My hair is doing insane things today. I cannot handle it. I'll go no construction. It's just like connect the dots. Just like we used to do as children. I'm glad you're vibing to the stream. 610. It's great news. If I can just provide a thing for people to vibe to, that's enough for me, you know? Well, it's not really, but that's good. Certainly not a bad thing. Connect 4. Not really connect 4. Connect the dots. Yeah, this is the side of a PCB, a flexible PCB. This one. Ooh, flexible. And so we're making a housing for it so that we can fasten it around my wrist so that I can do research on force myography, biometric pressure sensing. So this is kind of a I was going to say convex hull, but it's not totally convex. Concave hull, convex concave hull, human manually designed hull of the point cloud of what we need to cover. So that's kind of the design that I'm going for here. So that's the thinnest wall we can 3D print. Which, if we do vase mode, that could actually work, except for the part where that doesn't actually work. I feel like this should be fine. 2 walls. Stereolithography? No, not this one. This one's going to be FDM because it has to be a flexible 3D print. I don't have the flexible FDM filament yet. I could get it in the future, but I'm just less experienced with it, so I'm going to go for this for now. So this print should be able to complete without travel moves, which means I shouldn't have stringing, which means it should be good right out of the gate. I could also do a couple other things here. Yeah, you know what? That's not a bad idea. That's not a bad idea. Because who really cares about the other things that are going on under here? So in that case, yeah. I'm glad I did this. That's a good start. I'm going to take a couple of things from it. Take this and that and this and that and make this a little bit thinner. 0.3, 0.2. Okay. Then we can go to the side here and fill in our maybe rectangular sections, you know? Right, so got like from here to here, from here to here, from here. And you finally got it working, the hex display. That's very nice. Now, for this one is tricky. I want to make them all the same height. Call me crazy. Because it will add a little bit of stiffness to the whole thing. And that's kind of what I'm looking for from these sections. Not for what's in the middle, of course. Okay. All right. So that'll sit on one side. And that will be that. I'm not going to bother with the fillets right now. question, of course, becomes how do we keep these from separating? And if I'm being honest, I think the answer is a clip. A rigid clip. But we'll get to that later, maybe. Why not cast it in silicone? Because I don't want to ruin things, because I want it to be serviceable. Maybe eventually it'll be cast in silicone, but this is a research project. You know, if things go wrong, I don't want to have to start over. This is a research project. You know, once I know that this process is repeatable, blah blah blah, maybe I can cast it in silicone. But it's also not an easy manufacturing step for things. Literally eye-watering how fucking small you make things. Eye-watering is a crazy adjective for that. How the fuck will you put all those crazy dimensions off? How will you pull all those crazy dimensions off without breaking components? So, first of all, this part that I just built here, this thing, is a flexible TPU part, really flexible TPU, Ninja Flex. So, um, so um, like it probably won't break. To the cilantro sickness, yeah, tough. It's tough out here. I know. So there's a couple of openings that I need to account for in this. So this whole thing can slide in here, obviously. On one end, I think I want to have the empty soda can thrown at my head. It's an empty soda can thrown at my head. That's not good. I don't mean to be throwing empty soda cans at you. That's not my intention. This and that. Offset. 0.1. Honestly, this is so small. But it's going to be flexible anyway, right? So 0.02. And that's about it. What, this isn't a closed loop? Oh, I misunderstood where the sketch plane was. My bad. Oh, yeah, for sure. That I talk about something and then years or months later, that becomes your project of the week. I appreciate that. That's what I'm trying to accomplish here. All right. Did I not project this right here? Now. Whoa. Oh, it's not a closed loop, of course. Duh. So there. Now it's a closed loop. Okay. So this part, we'll take that too. Why not? Yeah, all of it. All of it. Go here. It really should be interesting if this gap is maintainable, you know? It's not that small though. I actually made it a little bigger. New body. Okay. And then we just combine. Can you put some sort of bridging piece at the ends to hold it apart? Please tell me, is it PCB design? Because I don't know what you did by using that software. So this PCB, I have it, a flexible PCB right here. And we're designing a flexible housing for it so that it's not exposed to the elements. That is serviceable. So that's what we have here. So the USB port sticking out here, and it's going to be printed in NinjaFlex. So this is a little bit precarious, of course. I think I might want to add some extra material just so that it doesn't sway so much while it's printing, but it shouldn't be too bad because it's already pretty stiff. If I add 0.5 millimeters here, that's not going to make much of a difference. So get rid of the sensor pads because we're not dealing with that right now. So this right here will print just like this, right? That doesn't seem too bad. You know, I might want to get rid of this because it's all one shape. It's not a broken shape. There's not islands. It's one single connected component, which means that we should be able to do it without travel moves over air, which means we should be able to not have stringing, which means it should be pretty easily assemblable. I'm always thinking about the manufacturing process when I design. Even though some of my designs might seem crazy, I promise you that I am considering the manufacturing process. So that will print, the PCB will slide right in. Then of course we have this side here that is exposed, which is not great. I'm gonna be real, not great, but should be actually pretty easily coverable. In fact, if I just extrude this another 1 millimeter, who's to say? Who is to say? This button also, I know for a fact, is a little bit, well, let's not worry about that actually. Let's look here. Because what I'm thinking is, actually, yeah, what I'm thinking, well, let's see. If I take this and that and this and that and this, and this and that and this and that and this and that, come on, buddy. Oh, and this and this and that 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 and this. Can I make it happen? I'm trying to think. I'm basically coming up with something I can like slot in. Yo, Jules, we got Jules. I don't have to call you out, Jules. Welcome. He's been trying to make it for so long. So my plan is essentially take this -2, -3, -4, you know, whatever it takes. -4 should be fine. Okay, so that's that. Then let's go here again. This is the only part I'm concerned about, but I'm going to deal with that later. Got to make sure I still see the SD card. Which means I need to, yes, force myography bits. Exactly. You got it. That is what we are doing today. It's SD card. So now you can see there are a couple ways that I can extend this whole thing. It already fits into the housing as it is. We're designing the housing right now. Oh no, my throat. Okay. So for instance, that line, that fits right over the existing SD card module. And then we also have this one. And this one. Actually, yeah, we'll start with that, but we have a lot more space than that, don't we? Actually, I don't even need that because that's way too far in. I think we only went 4 millimeters, so. You got me. Okay. The MCP 23017 expander, IO expander. It is the, it says right here. I don't think that's right. I've got to see this. Why can't I remember this? It's really hard to read right now. Pretty much the first thing that comes up when you search analog multiplexer. Yeah. CD7 4067. Is that what you said? Is that what you said? What did you say? No, that's not what you said. CD74HC 4067. Wait a minute. Are you guys seeing what I'm seeing? I had no idea. What? Oh my goodness. Okay, I'm sorry. Anyway. Right, so this is the plan. We got this, and we got this. And we go 4 millimeters in. Look at that. Look at that. And this shouldn't... 3.1. Okay, so 3 millimeters in. That's what we need to do. Yeah, it's analog because these are force-sensitive resistors, resistive sensors. We got some thin walls here. Let's fillet those away. Or rather, before we go over here, do a little snip, snip. Bam, got him. Got you too. Get rid of that. Get rid of that. Okay. Then let's go back to the future after changing the past, and good. Did I get the height of this button right? Because I really don't want it to be pressed down accidentally. 1.9 is what I have. 2.5, no. Okay, so I do need to generate a little update here. Looks too small, so we'll do minus 0.5. That'll be the button surface thing. 0.8. I mean, look, I hate thin walls, so we'll just do it like that. Make a new body. This body will be part of no, did I just do that? This body will be part of all PCB and will be part of button. Then we take this, take that, cut it with that, and keep the tools. Wow. I'm good. Okay. See, this is what I'm talking about. What is that? Doesn't matter anyway. Okay. So that slots in. I'm still a little bit like I think we need a little extra. But this is a good start. This is a good start. No, wait, what am I doing with this plane? I don't want a plane. Come on, man. going to offset this by 0.1. And then we are gonna project this, offset that by 0.5. Mm-hmm. Wow, new trick, double click to select the whole contour. I love it. Right, so that's what I'm thinking. This SD card might be hard to reach. How far does it stick out? Let's find out. Whoa! Guys, the camera. It fell. Oh no! Our table! It's broken! Okay. Put this one here. So, I think my caliper's running out of batteries. Let's see. But sticks out pretty far. Sticks out 3.6 millimeters. So as long as it's sticking out a bit, not a big deal. And I think it is, because I think we're only 2 millimeters out. Oh yeah, 3.6 is all the way out here. So that's totally reasonable. Nice, okay. So that's the SD card. Love that. The next thing is to just take this, project this, like is this enough? That's really the question. Is this enough? Make a new body. And what I might want to do, if I split face, where do I want to split the face? I think here. And then continue this part. Whoa. Okay. Guess we're splitting the face again. This face, split here. Okay. Can we just delete this? Nope. Okay. We're going to take that and that. And why don't we just make this a little bit more intense? 3. All right. I'm going to do a plane at angle 45 degrees. No, the other 45 degrees. Come on. Negative 45. Okay. Boom. Oh, God. Okay. We're splitting this one here. Nice. I'm going to chamfer this because I'm a bold man. Oh, no. Sure, dude. All right. Okay. That's something. That might just work. And it doesn't have to be perfect because this is a research project. It just has to be serviceable. I don't know what this is. But those are the parts for this cover. Okay. Yeah. Think. We need the wires too coming out. Where's the power line? Right there. Okay, perfect. That's where I wanted it. We need to fit this rectangle through. Let's do it that way. 8.7 by 2.3. Call it 9 by 8. Sorry, 9 by 3. 9 by 8. Something like that seems appropriate. Not this one, this one. Brother. Okay, we'll go here instead. You don't have a problem with that, do you? Wait. Sorry, I did wrong. No bodies except for that one. Okay, just cause. Let's bring these back up. It will still fit through because this is flexible. Don't do a dumb thing. You did a dumb thing when I specifically told you not to. Okay. And we'll do a little fillet action. All right. So that's for the power lines. And battery slot, I have an idea for that. It'll be like a rough kind of band, just a strap to hold the battery and the wire in place, because it doesn't need to be super fancy. 7.6 by 17.6, 7.6 by 17.6. That's pretty easy. Okay. So I think it's just going to sit on top of here. Yep. That is printable. Holy moly, brother. Give me a break. Come on. Okay. Guess we're redoing all the fillets, always, all the time. Okay. Just give it a good distance here. 20 millimeters if I can. Yeah, that'll be good. This whole thing is flexible. Actually, don't want one there. Okay. That can be adjusted as needed, but it should be stretchy enough to allow this thing to still bend when the battery is there. Okay. Fun. How about that? So that's the power lines, and then, yeah, the last thing is a little connector, just in case, and that'll be, okay, that'll be on the lid side. That's what I was hoping for. That's what I was hoping for. That means we can get a little bit more creative with the lid. I need to get a connector real quick. I promise I'll put the mic back on when I get back. I promise, okay, guys? I promise. I keep my promises. Okay, Blah 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 blah. Here we do. We have a 4-pin micro pico blade connector, which will work great for this situation. 3 pins and a ground, which are right there. So if I can get away with it, I'm just going to stick this right in here. 5.49 by 2.72. Let's see what that looks like. Oh yeah, that'll fit. 5.49, 2.72. Because we kind of want this to be in place, I'll go for 2.2 and 5. Heck yeah, dude. Not even a problem. Barely an inconvenience. 4.92. I don't know. That might be tricky. Let's see. What are we cutting? Cutting the body of the button. Oh, it sucks. Quite intensely, too, I might add. Okay, we'll make a new body and then assess. What about here? No one has a problem with that, right? Right? That's fine. We just add a little thing. We can just add a little thing. No one is going to care. No one is going to know. No one's going to know. They're going to know. It's going to be a circle. So it looks like it was all intentional. It was all part of a plan. Now, I'm kind of dumb. I don't know if you guys knew that. This might still work. I want to go with please, yes. I'm running out of patience. And I remember this doesn't have to be as polished as the other one. Oh, gosh. No. Let's not be crazy here. Come on. Don't be stupid. This is fine as it is. We just need like a little hole for wires to come out. Oh my gosh. I'm losing my mind. I've got to be off in like 20 minutes. So let's finish this up. Finish this up real quick. We just need the wire hole. Yeah, we We just need the wire hole. And it can be like a slot, you know. How about that? We just do like a rectangle here. All right. And the wires can fit out that way. So I have the wires fitting out there. And I am wondering how this looks. Dude, can I get a... Okay. Right. So then the last thing we need is, because the wires will come from down there, I'm just going to have a little spot. And it's going to be all rectangular, all kind of angled and weird. But I think it will work. Please give me electrical stuff. Okay. Okay, rectangle. Look, everything's flexible here, so I've got to delete these bodies. This is insane. Two sides. Dude. Okay, 75 is the one. New body. Okay, 75. So we need to cut 75 with 81. This is why I name everything, which I'm not doing right now, and that's a big problem. I'm a taxidermist, and my patients say I talk too much. That's pretty funny. Okay. The wires are going to have a little bit of room. Oh God, I'm so stupid. To kind of come through there. All right, let's isolate this real quick. I'm getting deja vu right now. I'm like, didn't I already do this? But no, I didn't. So this is not going to be printable because anybody can guess? This thing right here. Yo, can I get this thing, please? What's it gonna do? There we go. Okay. This is so ridiculous. Let's remove the stuff we don't need, because we don't need it. Okay, like 10 minutes left. Don't need that. Do need that. Don't need that. don't need that. All right. You know what I'm going to do? Just to keep this in place, well, does anybody care about this? Let's see. All right, 610's headed to work soon. And I gotta be out of here soon too. Just for shits and gigs, I'm gonna do what's called a pro gamer move and just make a 5 by 5, no, 2 by, because this is all stretchy material, 2 by 5 thing slot for the 1 millimeter for the connector to sit in, just so it has somewhere to be. Nobody needs to worry about it. Okay. Hooray! We've done it. Something that maybe will probably not work. But it's the housing and the cap. All caps, apparently. Okay. Remember, this is just for research, just so I can uncover the models that are required for force myography. I still need to add like something over here that allows me to add a strap, and then over here as well, something that can clamp on to here. Yeah. All right. Thank you all for joining, and I appreciate you all for coming. And the next time we're going to do some more stuff, and it's going to be great and not tedious at all. And I'm going to only make CAD decisions that make everybody happy, of course. Thank you all for coming, and I will see you next time. Goodbye.